What? Yeah.
Was set up. Is that what I saw?
Yeah, like when I sent that, this was all done.
Nice.
We really didn't have to do anything for 45 minutes.
Nice. They just don't sign into Wi-Fi. We checked the microphones.
We did. And I just checked the YouTube feed to make sure that it shows what is on there, not necessarily what's on here. That's the whole screen. Dustin can see the chat as well, so he's going to be able to flag you in for any chat questions.
Okay.
He's also going to do the audio check like Jordan used to. So he'll just stream it like anybody else. And just listen and make sure. I'll be right here, I think. That's where I'm going to sit. So.
Yeah, and I'm probably just going to stand over here and be like,
okay. And Jen's going to run around with the mic.
Okay.
So I don't have to do that.
Yay, I don't get the make fun of you.
I liked it.
I liked it too.
I know you did. I can tell.
You're like, stop. You enjoy this way too much.
It's filling up nicely, though.
Not as much as I expected yet.
I know. Got another 10 minutes or so.
I'm okay with that, as long as everybody else is. I mean, we usually start at 6:20. Do we still have that tape? Like, this being so far back makes me really nervous, and so many people have to walk this way. Like, it's
Well,
just,
Justin's going to have his computer connected to it, so he'll be paying attention. He's going to try to figure out how to do the screen share webcam thing in the future, screencasting it.
it's just that photographer-wise, we always like anchored everything down, and that leg is totally in the way. So if we have tape, we can tape it down. This is my past catching up.
I think we'll be all right.
You can give us tape though? I'll go get some.
Yeah, we got it up there. Next.
You guys ready to get started? Everybody grab your beers, get a fill up, and grab a chair. So all of the planner type A's are already sitting down and ready, and all of the wild, crazy people are in the beer line. Dean, you're in the beer line. Oh, can you turn the music off? So we are super excited to be here. This is our 5th Boulder Startup Week. So given that Analyze Boulder started 4 years ago, that also means that this is our 49th meetup that we've ever had. We have 220 Data Geeks members. With that many meetups, we've had roughly 150 talks over the 4-ish years. So none of this would happen without my team. So Justin, right here, and Jennifer are the founders. Woo!
my founding Smarty Pantsers. Thank you so much for putting this together. There's me, I'm Tony, and then we also have Greg and Eric. This also doesn't happen without Galvanize. They give us this space, they've opened our doors, and we used to bounce around in the beginning, and now we have definitely found a home that can house all of you guys. I can't believe that everybody actually got a chair today. So Galvanize does all kinds of awesome stuff. I'm sure with Boulder Startup Week, you have been here a couple of times or will be the rest of the week. Find out what they do, get on their mailing list, go to all of their free meetups. Awesome resource to have. None of this happens without you guys. So I want you guys to also give yourself a hand for being here. Thank you. Rick up here in the front is like, oh yeah. So normally don't go through like my own little message, but for Boulder Startup Week, we are on the diversity track. So I wanted to give you guys a little statistics. So I found out that there are fewer Fortune 500 CEOs that are women than named Dave. Or even worse, John. So from a mathematical statistical standpoint, this can't possibly be random. An entire population, 50-51%, it must be represented better than, you know, dudes named John. How many people here are named John? Okay, we got 3, yes! Are you guys CEOs though? Give them a break. How many people here are named David? Oh my God, seriously, no Davids? Daves? Did I scare them away? I'm so sorry. This is not a man-bashing event, I promise. How many women are here? Yes! All right, so a couple other statistics around that. Without diverse leadership, women are 20% less likely to win the endorsement of their ideas when you compare them, you know, to the white, straight, male. Again, not man-bashing, I swear. People of color are 24% less likely, and LGBT are 21% less likely. So 1/5, 1/4. How many people here have a supervisor or CEO that are part of one of these 3 groups? That's pretty awesome. How many of you guys are part of these groups and are the supervisor, CEO, business owner? Hi, got a few. What is that, like 5, 6? Way to go, yeah. Okay, now the positive side of diversity, right? And I know that you're not supposed to put this many words on a slide. If any of our speakers put this slide in one of the presentations that I review, I would tell them that, but you're stuck with me. So I'm just gonna read these to you guys. Ethnically diverse companies are 35% more likely to outperform their respective national industry medians. Gender diverse companies are 15% more likely to outperform those same industries. Companies reporting the highest level of racial diversity in their organization bring nearly 15 times more sales revenue than those with the lowest levels of racial diversity. And then lastly, employees of firms with higher diversity are 45% likelier to report growth in a market share and 70% likelier to report capturing a new market. Now I'm going to put you guys on the spot. Does anyone else have any other diversity statistics? I was working with a group through Go Code Colorado fairly recently, specifically on the challenge of bringing more diversity to the workplace. So they had all sorts of statistics. I know they're not here, so just thought I'd throw that out to you. If not, I'm going to pick on somebody. Hey, Rick. So, give him the mic, please. Just because we had a chit chat, he's got 1 or 2.
So I'm not going to quote stats, but when I worked in a company that was run by LGBTQ folks, the diversity in the company, at least with respect to sexual preference, was quite diverse.
Nice.
And we were in an agile contracting house. We had the most expensive rate of any company in the United States, and we were overbooked all the time.
Damn. Nice. Thank you. Thank you. All right, so that brings me to our 3 talks today. We are celebrating women, we are celebrating diversity, and we have 3 amazing people that are bringing all of these benefits to their companies. At least one of them, Diana, owns her own company. So our first speaker will be Alana Russell. She will be talking about measuring development talent and productivity using Git and Git metadata. Diana File will be talking about navigating startup life with deep learning. And Gretchen Riggs is going to be talking about convoluted neural nets to see man-made objects. Again, she's not man-bashing, okay? After that, we have the room until 8 o'clock. We're gonna kill the keg as much as possible and hang out data style. All right. I'm gonna skip this because you guys are so awesome and already putting money in the tip jar, or in the beer jar, I should say. But this is kind of a breakdown of what we spend the money on. None of us get paid, so yeah. That's that. We'll skip that real quick. What? That's why you're wearing that shirt. Anyone that's new to this meetup, who's the first time you've been to Analyze Boulder? Yay! Thank you so much for being here. We like to chit chat and get connected and help each other out. So pull out your cameras, take a picture of this, join our Slack channel, join our LinkedIn channel, especially if you're looking for a job. Join Twitter, take pictures, make comments, tweet tonight, all of that good, awesome stuff. We really want you to feel a part of the data community here in Boulder, and we want to make that happen for you. And yeah, lots of jobs have been found through connections here. And also cool, nerdy projects and meetups, which is going to bring me to my next slide. Anyone looking for a job? Anyone have jobs available that you can tell the crowd about? Who's hiring? Right there.
No, I'm not hiring. I'm looking for a job.
Tell us what you're looking for.
Well, I'm graduating with my PhD in applied mathematics
Whoop.
in August. So I really like to get into the data type field. I'm very open-minded about whatever work I'd be going into. I have a broad mathematical skill set, so I'm just excited to explore and learn new things.
Awesome. Who else? I saw a bunch of hands.
We're hiring. I work for a company in the East Coast, so it's for telecommuting only, obviously, unless you want to commute to the East Coast every day. The company's name is Haystacks Technology. We specialize in Bayesian networks, where we develop techniques using qualitative language to construct large-scale Bayesian networks on the order of, say, 800 to 900 nodes. Then we apply machine learning techniques to apply evidence to some of those nodes.
Awesome.
And so we're hiring for data scientists. We're also hiring for a chief data scientist as well. If you're interested, you can come contact me after the meetup.
Awesome. I just met this mathematics PhD, if you're interested. In the back.
I'm here, so I just graduated with my PhD. Also in math.
Woo!
Kind of similar, but also looking for jobs here and out east.
Interesting. So you could go work for Haystack and you wouldn't really need to commute 15 hours a day.
Right.
Any other jobs? Who's hiring? Oh,
The concentration right here in this room. So hi everybody, I'm Neil. I work for Mesosphere. So we cultivate the Apache Mesos project. So anybody that's interested in distributed computing, Mesos, data science, Kafka, Cassandra, databases, all that cool stuff. We're hiring engineers, hiring a lot of people, honestly.
awesome.
Sales, product. We're based in San Francisco, but we are on live here, so I'm proof that we can hire outside of there. But anyway, I'm Neil. Come talk to me.
Thanks, Neil.
It's going to be super vague, but we're going to let the CU use it on short term or rapid utilization, maybe 1 to 2 years, whether it runs out. So, you know what that means or that's experience.
I actually had a hard time hearing that, so just to make sure that you get leads. What was that?
CU lab, short-term graph database visualization.
Awesome. He's a regular. And then we've got Eric.
Hi, my name is Eric. I actually recently started working at Ibotta about a month ago. It's an app designed in Denver. It does cashback, like coupons kind of deal. We are hiring a lot of people. I think we have like 45 positions posted currently. A lot on the analytics team, so should check it out.
Nice. And Eric used to teach at Galvanize, and so he's probably going to be an awesome mentor. If I had to guess, number one. Top notch. What about events? Aside from Boulder Startup Week, any hackathons going on? Got one back there. Any conferences, any workshops, learning opportunities? Anybody just looking to collaborate on a cool, funky project?
Hi everyone, I'm Sarah. I am one of the co-organizers of Women in Machine Learning and Data Science.
We're also really cool.
Just wanted to announce our next event, June 27th. It's going to be a tutorial using Apache Spark. We'll be using the Graph Rankings API to do some sports analytics. So it's pretty cool.
Awesome. Yeah, who's got other meetups that they lead? Anything? Anyone doing cool, nerdy stuff for summer? You're just keeping it to yourselves, aren't you? All right. Well, I think we can start our talks now. Without further ado, let's bring up Alana Russell.
Hi. I'm Alana, and I'm going to talk about productivity for software engineering. Have you ever received a product spec like this? They're essentially asking you to build a time machine. Here are all the parts, and there's no manual. All joking aside, state-of-the-art engineering management looks a little bit like this. It can be interruptive, a lot of different shoulder tapping. Let's take, for example, the daily startup. Most often, everyone says everything is fine. When was the last time someone stood up in a room in front of their peers and said, hey, I know I said I was going to deliver this today, but it's actually going to be 6 months late. We can take a look at other simple, readily available metrics like lines of code. But this doesn't always paint a clear picture. Let's say, for example, Scott. He's been working really hard, but half of his work is going to be thrown out within a week. What if we could identify that he was really just experimenting on a new feature? Or maybe his product requirements weren't really that clear. How many of you guys have heard of Git? Yes. Okay, so just in case there's a few of you that maybe aren't familiar with Git, it's a version control system. And a lot of these questions can be answered by looking at the deep history of your code base. Maybe there's an indicator in there to show that your churn or things that are being thrown out are higher than average. Typically, 10 to 12% of engineering work is experimentation. But what happens if this suddenly jumps to 40 or 50%? Maybe it's worth looking into. We could also take a look at commit frequency. How often, on a daily basis, are authors contributing to your code base? Typically, 3 days is about average for developers to be writing. But what happens if your team is only committing 1 to 2 days a week? Maybe it's an indicator of high political overhead or unclear product requirements. Without data, it's really hard for engineering leaders to understand what's going on within their team. A lot of times they seek out a mythical 10x engineer. But what if instead we identified 0.2x managers? These 0.2x managers could be slowing down their teams. What if we were able to empower them and make them 2x managers? Then suddenly you have a much stronger engineering team. What if, in addition to get metadata, we could layer in pull request metadata, tickets to better understand what features are being deployed, and also better understand what meetings they're attending or when they're out on PTO. Wouldn't it be great if we could quantify technical debt, or if we could understand when we need to make better specifications? We're currently doing this at Git Prime, but if you want to get started on your own, there's a great open source library, Git Python, that has a lot of abstractions that you can get started with on your own. I'd love to connect with you, and here's my Twitter handle.
All right, we're opening the floor for any questions.
So, do you have examples of improvements that you can? Do you have examples of improvements that have been done to what you've created?
Yeah, so we have a couple different blog posts, but the one that stands out is a lot of times developers commit locally and they don't always push their commits. And we've seen that prolific engineers, ones that are able to commit in smaller bite-sized chunks, tend to have more impactful commits. Do you want to ask a follow-up question?
Show the stats.
I actually don't have the stats, but I'd love to. I can follow up with you and show you. And then it's also available on our blog post online.
More questions?
Yeah.
How can you, maybe you already went over this, how can you tell if a commit is impactful or not?
So we actually developed an algorithm, and I don't have a backup slide for this, but it's so you can take a look and see that there's so many lines of codes, but as the insertion point on a lot of different files. And are you creating new code, or are you rewriting old code? So taking a look at 5 different measurements to understand that maybe that commit versus like a 500-line new greenfield commit is more impactful and has a higher cognitive load. Yes.
Do you use git blame as a factor in your analysis?
Repeat the question.
So the question was, do you use git blame in a factor of your analysis? We keep track of the author, and that's actually just a part of the metadata.
Since people are quiet, we'll bring up Diana right afterwards. You showed a graph where it's like, oh, okay, maybe it goes up to like 40%.
Mm-hmm.
Who is the person that ultimately judges whether that's too much churn or not enough churn, and how do they do that?
So with the analysis that we did, we analyzed over 1 million commits just to find kind of like a standard. But it's really team by team. So it depends, like maybe your team is being super innovative, working really fast, not totally concerned about technical debt, and 50% is normal. But if your team suddenly is, they decide to rewrite everything and you want to look and see and better understand why, it's good to have that history, and it's all in your Git metadata. So.
Thank you so much, Alana.
Yeah, thank you.
So Diana used to be on our leadership team, and so she is near and dear to our hearts. I knew that I wouldn't have to QC her slides very much, but when I looked them over, they're really funny. So enjoy it, Diana File. Thanks so much. So I've been learning about neural networks and deep learning, and for Boulder Startup Week, I wanted to do a fun project related to startups. So one of my motivators was these awesome deep learning Twitter bots that I have been fascinated about. And the way that these work is they use recurrent neural nets, which I'll talk about in a second. And they generate one character at a time until they meet 140 characters of limit. And in this case, this is trained on Donald Trump's speeches. And I love that there's a hashtag at the end. So these recurrent neural nets can be pretty powerful, and I wanted to play with it and try it out and see what I could do. So who's everyone's favorite Boulder-based VC who also writes a ton of stuff on his blog? Well, there's this guy, Brad Feld. So I decided to scrape his blog. For those of you unfamiliar, he's written thousands of posts on startups and mentorship and mental health, and I don't know where he went to the movies last weekend. So he's pretty prolific. So, and he, after scraping his blog, I had about 7 megs of data. I actually stopped my script early because I had to go home. So there's probably more like 7.5. But anyway, so I started with that. And then I applied my recurrent neural net. So this is a feed-forward regular neural net, and for those of you who haven't seen this, there's some really powerful theorems that tell us that we can actually represent any continuous function with some caveats using this kind of structure. We have this network that goes forward, and there's weights into and out of the hidden layer, and what's called an activation function, which adds a nonlinearity. And that's all to say that we can build up a network like this, and we can represent any function. Here I took a mountain lion picture from my neighborhood last month, and I want the neural net to learn if this is a cat or not a cat. That's the function that I'm representing. With recurrent neural nets, these are used a lot in speech recognition and anything that has a pattern. So like if my sentence is mountain lion, and if I feed my neural net an M, I want it to predict an O. And that's how I train it on my text. So this is a regular recurrent neural net. All the hidden layers are like in that A. So the picture that you had before, it goes upwards. This is kind of confusing. We'll just move on. So what makes a recurrent neural net powerful is this idea of a long short-term memory. And that just gives context. So if you started talking about mountain lions like 3 sentences ago, it's a way to just remember what you said a while ago so that you can now finish your sentence with roar, because you remember. Okay, so I used a recurrent neural net library, and in order to generate text from Brad Feld's blog, I played a lot with it. The trickiest part with deep learning is figuring out a great neural net architecture. So I played around with the depth, which makes it deep as you add more hidden layers. I played around with how many units there are in each layer. I played around with all kinds of stuff. And so here's my first sentence of text. So it's kind of gobbledygook, but hell is right next to the word lawyer, so that's pretty impressive. And it does pick up like semantics and grammar and structure, so I'm always really impressed when there's an open parenthesis that gets closed. That's not here, but I find that pretty amazing. And that's like the kind of stuff that these networks can pick up. Here's a bunch of more sentences. It's like, it doesn't quite make sense, but it sort of makes sense. So I don't think we're all going to become really enlightened from generating this automatic Brad Feld text, but I had a lot of fun doing it. The last thing I'll show you is that I seeded the text with fun stuff. So Brad Feld might say, analyze Boulder as entrepreneurial communities, which is sort of right, I don't know. Okay, so the stack that I used was I used Python to scrape everything. I used a library called TorchRNN for the neural network, and I used a GPU instance on AWS, which was another part of the learning for me, and it took many hours actually to install all of the Luogit and Torch libraries and like get all of the GPU stuff going. But after that, it ran very smoothly. I would set off a run, and 8 hours later, I could check if it worked well. So it was a fun process. And here's some resources of my favorite RNN-related resources for this project. Thank you. Questions?
So did you show these to Brad?
I did ask permission to use his picture, and I sent him a couple, and he said, cool. Any other questions?
I'll just try and talk loud. What would you do next to try to get less than gibberish on?
There's a lot to play with, so I didn't do as much playing with the learning rate, and that's what helps it really converge. I tried adding a lot more layers, and eventually so the text that you saw was 4 layers deep, and by then I wasn't doing as well, and so I think I could train it for longer and play more with the learning rate. There's a lot more you could do. You could change the activation functions. I could spend a lot of time on this, and I'm probably gonna move on. But there's a lot of tweaking, and that's why you need 20 GPUs at least to do something that is actually not a pain where I wake up 8 hours later to press the button again. Go ahead.
Training cycles, that box.
This was 50 to 75 epochs of training cycle. That means that we ran through all of the 7 megs of training data 50 to 75 times. I think on the one that I showed it was 50, but then I did another one that was 75, but then I didn't feel like changing the slides.
One more question?
So you mentioned that you would go through it for 8 hours. What do you get out of it after 8 hours?
The question is, what do I, after running this thing for 8 hours, what happens? What I could have done was I could have looked at the objective function and how it goes down and whether it's converging and what it's doing over that time and stop it early, but I never did that. So at the end of it, what I would do is check if when it converged and check those numbers, and then usually I would just generate text. And the first couple times I did it, it was way more gibberish than this. And then I would think, oh, it's not picking up even parentheses, so I'm just gonna go deeper, and then I'll just add another deep layer and try that. So it was very ad hoc.
So it gives you a model that generates text?
Yeah.
Other existing weights, just basic for English language that you start with. Transfer learning is a thing. But it's starting from scratch. Are you starting with
The question is, are we starting the weights from scratch, or do we have some pre-trained network that we use? And the answer is we start from scratch and we just initialize all the weights randomly. Is that, or that's what I did.
So there's no English language package that you can start with?
So Torch RNN, which is this this package on GitHub, does pretty much everything for you. And so you can change some things around, if you're going to change the activation function or initialize the weights in some way, you have to go in and do that. But this does, anyone here can just spin up a GPU instance and run this stuff.
Any last question? Going once? All right. Thank you.
Our next speaker, Gretchen Riggs, also has a neural net. It's a little bit different, and she is a galvanized data science graduate. Was Eric your professor, if you will?
Yes, he was.
Oh, what was he a good mentor? I have to know.
He was very good.
Gretchen.
Hello, everyone. All right. Is anybody in the mood for some trivia? Yes, awesome. So can anyone tell me when the idea or the concept of the artificial neural network was first introduced? I guess would be fine.
Throw it out. Say it loud.
Who said 58? That was the closest. 1956. Oh, I was after I said. Was it you, sir? Okay, yeah. Pass this guy back. T-shirt for you. Sorry, man. Sorry. I was afraid that was All right. How many layers are there in a deep neural network? Oh, I guess that's a little. I don't know if that would be open-ended. What's the minimum amount? Oh, jeez. Oh, woman. Has to be a lady. Diana, oh. Yes, that is correct. Left-handed. All right. What is a rectified linear unit, also known as ReLU? Brian? No.
It's 0 if it's less than 0, but the number is greater.
That's right, Sam. I'm sorry though, I'm out of t-shirts. Hardest question, and I'm out of t-shirts. Well, my project that for my capstone project, this was for the Galvanized Data Science Immersive Program. I used all of these things, and it is entitled Nature or Not. And I trained a neural network to recognize if there was a man-made object in a satellite image from around the globe and around extraterrestrial globes. Now, this would be useful for reconnaissance, for monitoring land use, and yes, for finding signs of intelligent life on other planets. I think so, yes. But I didn't use a traditional neural network for this. I used a convolutional neural network. Well, what's the difference? Well, the main difference is that a traditional neural network has full connectivity between all of the neurons in one layer and the neurons in the next layer. That could end up to be a lot of connections. Well, with the convolutional neural network, we have sparse connectivity. So we're just looking at the neurons in a local area in the next layer. Now, this is achieved by making the filter of weights smaller than the input image. So as we see here, this little red box is our, well, just for this demonstration anyway, this is the kernel, and it slides over our image and convolves just that part of the image with a filter, which is initialized with random weights in the beginning, and when it goes through the neural network updates. And this is done for a number of filters, whatever you specify, to create a number of filter or feature maps. So the neural network is learning different features, such as perhaps the differentiation between pixels, the darkness level, and perhaps shapes and color. And here we go. And here's the data. I got the data from using the Google Maps API and also from manually capturing some images. So I could make sure that my classes were balanced. I have about 50% natural images and 50% of images containing a man-made object, which may contain like plowed fields and orchards and that kind of thing, since those show patterns that were made by man. So I had to cut these images down to 124 by 124 by 3 size to make my convolutional neural network work using the compute power I had. And then I augmented my data set by rotating each image and also by taking mirror images of all the rotations. I had to hand label one set of the data, and I was able to copy those labels over to the other 7 sets, so I saved myself a lot of time. And I ended up with over 50,000 images in my train and test set. And this is what my convolutional neural network ended up looking like. So I have a convolutional layer to begin with an activation function of ReLU, which we discussed in the beginning here. Go into another convolutional layer with an activation of ReLU, followed by a max pooling layer and some dropout. Now those two things help deal with Any overfitting, help our model generalize better to unseen data. Then it goes into another convolutional layer, another max pooling layer with some dropout, and then finally into a fully connected layer, which then goes through the softmax function, which is a generalization of the logistic function. And it will come up with a probability of being natural or containing a man-made object. And my results. So ended up to be about 85% all around for precision, recall, F1 score, accuracy, pretty good. So I thought, hey, wouldn't it be fun sticking some Google Mars or Google Moon data, see what we can find out there. Well, it ends up, believe it or not, about 50% of the Moon and 50% of Mars contain some form of intelligent life. Or it could just be that my model was trained on Earth data, which was colored, and did not have a whole lot of deserty crater kind of images. I'll leave it up for you to decide. So here are my data sources from Google Maps and my technology stack. And my name is Gretchen Riggs. Are there any questions?
Question? Go on front.
Sure.
So what is the 85% accuracy based upon?
The number of predictions that were made correct.
Yeah, but how did you determine correctness?
Oh, because I hand labeled the picture. Well, they were based on what was labeled versus what was predicted. So.
So you kind of, I guess the questions about class and balance, given any sort of idea about, well, the field satellite imagery in the world, I wouldn't imagine it's 50-50. Do you have any sort of testing around introducing a class balance that's more reflective of what you see in the world? Right, so if you go to the moon, it's definitely 50-50.
That's right. So I would have to say to be able to do anything with Google Moon or Google Mars or whatever planet, we would have to have some data that more closely represents what we're seeing there. Yeah, that was my thought. Like maybe go out in the desert and get a lot of crater images. And of course, grayscale versus color is very important. So.
So do you know what kind of features are being identified as being man-made in the Moon and Mars data?
There are, well, the circles on the craters, since it's a pretty regular shape, I believe it's finding that the pixel differentiation at the edges, I think it's finding that is so regular that it's considered man-made, because the images on the Earth might be silos or something like that. So yeah, the training data did not really represent the Moon or Mars. Yeah, that was just a fun little aside, but.
This may be a question about using these things more in general, but I was struck by the use of 50-50. And medicine has run into this problem over and over again. They develop a test in a hospital that does a very good job of discriminating 50-50. And then they go out where the base rate is 1% or lower, and the test works awful. And what do you think would happen if you varied the proportion of hits and
I don't think my metrics would be, well, at least the accuracy wouldn't be necessarily appropriate to use to judge if it was coming out good. Whereas bringing something in like the F1 score, looking at the precision and recall also is important.
How did you decide the zoom level? Because something like coastline, the closer in you look, it's going to look much different than a farther out zoom.
I zoomed in Google Maps as much as I could. I tried to get as close as possible, I think, which was, shoot, I think it was like maybe 100 to 200 meters within the view. So yeah, I tried to be consistent with all the images. And then with the moon and the Mars data, they did not have the scale on them either. So really, if they were at the correct zoom level, perhaps. Yeah, because those craters, I mean, it would probably be a partial circle or something.
One last question.
How did you choose a network architecture, and have you tried leading others to see the movement from differently?
I tried using less layers. I tried doing more dropout versus less dropout. I changed the activation function between like tang and ReLU. And I think after the project was over, I actually added another convolutional layer and got a little bit better scored, but it's too late to add that in. So it was kind of just trial and error, what things could be changed and turning off switches and turning them back on.
So I lied, I have a question now. Doing a convolutional neural network, was the main drive to do it that way, just computing power to save some of that resource?
No, it's generally how like image recognition, that's the tool that's used. And because you're seeing the relativity of the pixel values next to each other, I mean, they have a relationship that, I mean, you wouldn't see if you were looking at each individual pixel. So.
Thank you so much, Gretchen.
Thank you.
All right, so Greg is going to go back to my slide deck. Since most data people are fairly introverted, I'm going to provide you a few questions to go ahead and ask each other while you're in line for beer and all of that other good stuff. Thank you so much for being here. Please stay. We have the room for a bit, and we have lots and lots of beer left. And thank you so much. I hope you enjoyed our time here.
Music? I don't know why it's so hard for me to put music on the supercomputer.
Oh, all you gotta do is go to I just set up my phone.
This is like not my computer? Oh, okay.
Yeah, and then space bar to get it going.
Awesome.
And go back here and enter. And enter. Doesn't want to work.
Sweet!
It should be command enter. Yeah.
Yay! I know. And I'm like, Diana, damn it!
Is the music on?
It should be on, yeah.
Okay. I think I found. I've been searching the internet for quite a while. I can't think of 6 nonprofits of any kind that want to hire an ensign. But yeah, so now